class we are going to discuss EMF of a galvanic cell, means how to find EMF of a galvanic cell. That is basically it is how do we apply Nernst equation to find EMF of a galvanic cell. So, it is application of Nernst equation to different types of galvanic cells. For example, as usual, again if you take metal ion galvanic cell, suppose if you take this zinc Zn2 plus Cu2 plus Cu, this if you take from Nernst equation, E cell is equal to E naught cell minus 0.059 by n log Mn plus. This is what the Nernst equation says. So, now this if we apply, this is for a single electrode. So, from this if you write E Zn2 plus by Zn is equal to E naught Zn2 plus by Zn minus 0.059 by n log Zn2 plus. This is for a zinc single electrode, and similarly E Cu2 plus Cu is equal to E naught Cu2 plus Cu minus 0.059 by n log Cu2 plus, and here n is equal to 2 as it involves 2 electrons, right. Now, overall E cell is equal to E naught Er minus El. Er stands for, so overall in a galvanic cell, cell EMF is equal to EMF of right hand electrode, that is reduction electrode, minus EMF of left hand electrode, that is oxidation half cell. So, E cell is equal to Er minus El. So, this is equal to E naught Cu2 plus Cu minus E naught Zn2 plus Zn minus 0.059 by n log Cu2 plus Cu2 plus my 0.059 Er minus El. So, this is E Cu2 plus Cu minus E naught Zn2 plus Zn minus 0.059 by n log Cu2 plus 0.059 by n log Zn2 plus. So, here this is basically E naught of this minus E naught of this minus E is 0.059 by n log Cu2 plus minus 0.059 log Zn2 plus. So, that minus minus will become plus, and finally, it becomes like this is, we call it as E naught cell, E naught Zn2 plus by Zn minus E naught Cu2 plus by Cu minus E naught Zn2 plus by Zn is what we call it as E naught cell. So, we can write E cell as E naught cell minus 0.059 by 2 log Zn2 plus by Cu2 plus. So, this is what finally how do we get it as EMF of this galvanic cell, zinc copper couple. EMF of zinc copper couple can be determined as E naught cell minus 0.059. This 0.059 for all practical purposes can be taken as 0.06. So, 0.06 by 2. So, that our calculation will be simple, log Zn2 plus by Cu2 plus, that means concentration of zinc ion by concentration of copper ions in the solution. This is how simply we can determine the EMF of a galvanic cell for metal ion electrode type, right. Now, suppose if we have a metal non-metal, then how do we determine that, we will see next. Now, suppose if we have the zinc electrode for say for a hydrogen electrode, which we represent it as H plus by H2. So, for this electrode, so the hydrogen electrode we represent it as H plus aqueous of certain concentration C, H2 gas. This is how we represent it. The equation is 2H plus 2H plus 2 electrons to give H2 gas. So, for this if we apply this is a hydrogen single electrode. So, for this E H plus H2 is equal to E naught H plus H2 minus 0.059 by n log pH2 by H plus square. Here the Q is equal to, for this reaction, Q is equal to active mass of hydrogen gas by active mass of hydrogen ion concentration square. So, it is active mass of hydrogen gas by active mass of H plus square, which you write it as, for hydrogen gas the active mass more accurately we express as pressure of hydrogen by, for aqueous H plus ion the active mass is molar concentration. So, we write it like this. Okay. Now, E naught H plus H2 is equal to 0, because for a standard hydrogen electrode the E naught value, E naught is 0. Okay. And if pressure of hydrogen is 1 atmosphere, then E H plus H2 is equal to minus 0.059 by, here n value is 2. So, 2 log 1 by H plus square. Therefore, E H plus by H2 is equal to, now this 2 and this 2 cancels. So, it is 0.059 log H plus, because when it goes to numerator then the 2 cancels and this becomes minus, that minus will become plus. So, this will be E value for hydrogen electrode. This I write it as minus log H plus is pH. So, in terms of pH if I write E H plus by H2 is equal to 0.059 pH, and this is minus, because minus log H plus is pH. So, E H plus by H2 is equal to minus 0.059 pH minus log H plus. So, in case of a hydrogen electrode, depending on what concentration of hydrogen ion that we take, of course, the pH of the solution also reflect that. So, EMF of a hydrogen electrode you can express in terms of the pH of that electrode, right. So, this is simplest way of writing the EMF of a hydrogen electrode, or giving the relation between EMF and pH of what you call the hydrogen electrode. So, now if you have again using a hydrogen electrode, suppose if you have a complete galvanic cell, if it is given like this, Zn2 plus aqueous concentration of certain concentration C1, hydrogen ion concentration aqueous C2, hydrogen gas at pressure P with platinum. So, here cell reaction is equal to Zn2 plus aqueous and of course H plus. So, cell reaction is zinc metal with hydrogen ions to Zn2 plus aqueous plus H2 gas. This is the cell reaction. So, for this if you write Q, Q is equal to Zn2 plus into pressure of hydrogen by H plus square. This is the Q. Now, E cell is equal to E naught cell, that is E naught R minus E naught L. E naught R is E naught H plus by H2 minus E naught Zn2 plus by Zn minus 0.059 by N, the N value is 2, log Q, Q is Zn2 plus pH2 by H plus square. So, this all if you simplify, this of course, this value is 0, irrespective whether you write it or not. I will write E cell is equal to or simply E naught cell. This E naught cell is nothing but now minus E naught Zn2 plus by Zn, because this is equal to 0. E naught cell minus 0.059, these two will get cancelled. So, I will write it as 0.059 log Zn2 plus, if pressure of hydrogen is 1, then it is Zn2 plus by H plus square. So, it is into H plus square, considering pressure of hydrogen is 1 atmosphere. So, this is the expression for zinc hydrogen galvanic cell. For a zinc hydrogen galvanic cell, the Nernst equation can be written like this. Now, next we will see how to write, how to apply Nernst equation to a calomel electrode or in general to a metal insoluble anion electrode. Now, suppose if we take AgCl, Cl minus, this is again consider it as a half cell. For this, the cell reaction is the half cell reaction. The cell reaction is that AgCl plus electron to give Ag plus Cl minus. Now, this metal insoluble anion electrode, this cell reaction can be written like this, where this is considered to be a reduction half cell. If you consider it to be a reduction half cell and the other way around, if you look at it, then Ag gives Ag plus electron. So, overall reaction is that AgCl gives AgCl to give Ag plus Cl minus. So, for this Q is equal to Ag plus into Cl minus, which I will write it as KSP. Now, the two half cells separately if you write AgCl Cl minus is equal to E naught AgCl Cl minus 0.059 by N log, for this Q is equal to Cl minus, and Ag plus Ag is equal to, for this second half reaction if you write, for this Q is equal to concentration of Ag plus, that if you write E naught Ag plus Ag minus 0.059 by N log Ag plus. Now, these are the two half reactions of a same electrode, same galvanic cell rather. These are the two half reactions of same galvanic cell, in which one of the half cell is metal insoluble salt anion electrode. Okay. Now, so that way if you consider, now this must be equal to this, the EMF of this half electrode must be equal to EMF of the second half electrode. So, now considering that these two as two half cells of same one galvanic cell. So, then in that case EMF of one half cell obviously will be equal to EMF of the other half cell. So, it will be E Ag AgCl Cl minus will be equal to E Ag plus Ag. Therefore, E naught Ag AgCl Cl minus 0.059 by n log Cl minus is equal to E naught Ag plus Ag minus 0.059 by n log Ag plus. So, now if you look at it, therefore, from this what we can write is that E naught Ag AgCl Cl minus is equal to, take it on the other side, you write E naught Ag plus Ag minus 0.059 by n log Ag plus this 0.059 by n log Cl minus. So, this I will write it as minus 0.059 by n log Ag plus log Cl minus. So, this in turn is equal to E naught Ag plus Ag minus 0.059 by n log Ag plus into Cl minus, that is equal to log Ksp. So, E naught Ag AgCl Cl minus is equal to E naught Ag plus Ag 0.059 by n log Ksp. So, from this, from the EMF, so basically the point is that, so here because Ag plus into Cl minus is equal to Ksp. So, this is what exactly we wrote it over here. So, from this what you can say is that from EMF calculations, from EMF measurements, Ksp of insoluble salt can be determined. So, this is one very important application also we can say that using the EMF measurements for any insoluble salt, if the solubility product is not known, then construct a galvanic cell using that insoluble salt and find the E naught values and calculate E naught of, in fact, E naught of Ag plus Ag is already known. E naught of Ag plus Ag is already known in what you call the electrochemical series. So, from that, from the table of electrochemical series, if we get a E naught of Ag plus Ag, then we can determine the Ksp of the AgCl. This is a very important application of EMF measurements. Nernst equation, very important application of Nernst equation in determining the solubility product of insoluble salt. So, based on this application of what we have discussed for metal insoluble salt anion, calomel electrode which is Hg Hg2Cl2 Cl minus. For this, E naught of calomel electrode Hg2Cl2 Cl minus is equal to E naught Hg22 plus Hg minus 0.059 by n log Ksp of Hg2Cl2. This is for calomel electrode. So, using this equation, the E naught for calomel electrode is determined, which is available also now in the tables, and this is what we used as secondary reference electrode. The primary reference electrode is hydrogen electrode. Primary reference electrode is hydrogen electrode. For hydrogen electrode, the EMF is determined, the EMF is considered as 0, as already previously we discussed. So, it is E naught for this is taken as 0. Using this, the what you call for calomel electrode E naught value is determined, and that will give you the values for secondary reference electrode. This is used as secondary because here what happens, hydrogen electrode is what we told it as reference electrode, but hydrogen electrode cannot be used conveniently every time in the laboratory. So, hydrogen electrode directly cannot be used always as the reference electrode as and when it is required. It is difficult to prepare standard hydrogen electrode, and it is also difficult to maintain standard hydrogen electrode. Keeping this in view, some other secondary reference electrons have been made, have been constructed, and are being used in the laboratory. The secondary reference electrode, one such secondary reference electrode is calomel electrode, and other secondary reference electrodes are the quinhydron electrode, glass electrode we have. Now, those things we will see later, but this is a calomel electrode. So, this calomel electrode E naught is determined, and that is used as a reference electrode to determine the EMF of any other single electrodes in the laboratory. Any unknown electrode, if it is given, the EMF, the E naught value of that electrode is determined by taking the E naught value of this as the standard, and we determine the E naught value, that is standard reduction potential of any other single electrode. Now, we go for quinhydron electrode. Now, EMF of a quinhydron electrode. Quinhydron electrode is so this quinhydron electrode is the reaction of quinone and quinol. The quinone-quinol reaction is what we take in, what we use in making this quinhydron electrode. This is of course, the representation of quinhydron electrode is like this. This is quinone and this is quinol. Quinone and quinol is represented like this. So, here what actually the reaction is that quinone is reduced to quinol. This is quinone. Quinone is reduced to quinol. So, here for this, if you write the Q is equal to active mass of quinol by active mass of quinone. So, for this E of this QQH2 is equal to E naught QQH2 minus 0.059 by N. This N is again equal to 2 log QH2 by, this is QH2 by Q into H plus square. So, here what is the pH of the solution is very important in determining the E. Now, this E naught value is again determined using the standard hydrogen electrode, that is a primary reference. Using standard hydrogen electrode, the E naught of this is determined, and that E naught is actually the one from which we use it as the secondary reference electrode. For any concentration of quinone, then E will be determined like this. So, this is the quinhydron electrode, right. Now, next we see something called concentration cells after this. So far, because here what we have completed so far is what is a galvanic cell, what is the construction of a galvanic cell, what is the principle of a galvanic cell, how working of galvanic cell, and how to find the EMF of a galvanic cell, what is Nernst equation, how to use Nernst equation for different types of electrodes and different galvanic cells. The next topic is what you call concentration cells. This concentration cells is one particular type of galvanic cell, one specific type of galvanic cell that we will discuss next.